Hey everybody, so in this video we're going to look through the solutions to our test that we just did on sets and probability. So we'll start with the first one. We'll just go through things as quickly as we can so the video doesn't go on forever. So this first question asks us to list the elements of the different sets in the above diagram, right? So for A, if we look at the circle A, we get the elements 2, 3 and 4 inside this circle. So our answers are 2, 3 and 4. Ideally we put them inside in these curly brackets. But I've said that it will also accept 2, 3, and 4 without the brackets. For 4, 5, and 6, same deal. We look at the circle B. It's got 4, 5, and 6 inside in that set. The universal set, remember the universal set is everything inside this whole box, or everything that exists in the universe. So we have 1, 2, 3, 4, 5, 6, 7. 1, 2, 3, 4, 5, 6, 7. A intersection B, remember the intersection is where the two sets overlap, so that's just going to be the element 4. A union B is if we combine A and B into a big mega set, we get 2, 3, 4, 5, and 6 inside in that mega set that's combined of A union B. Like if the countries in Europe formed the European Union, you'd shade them all in on the map, so shading in all of A and all of B, 2, 3, 4, 5, 6. A complement is everything apart from A. So if we look at 2, 3, and 4 inside in set A, we're going to count everything apart from that in this set. So A complement, that's what the little dash means. So we're going to have 1, 5, 6, and 7. 1, 5, 6, 7. Then we go on to B slash A, which may be B less A is a more common way you've heard of that. So that's the set B. We take away anything that's also in A. So we have 4, 5, and 6, but we're going to take away 4 because 4 shows up in A. We're just left with 5 and 6. And then finally we have A union B and complement. So A union B in brackets. So that's our set. And then we've got this complement thing, which is everything apart from A union B. So A union B is 2, 3, 4, 5, 6. Right, the mega set that we get from combining A and B. We're going to list everything apart from that. So that just leaves us with 1 and 7. Okay, so now we'll look at the second question. We've got a class of 28 students was asked to do a test. There was 2 questions, and we're given some information about who was able to answer each of the questions. Then a good idea would be to draw out a rough version of the Venn diagram, and then we want to compare it with the blank diagram below. Use your Venn diagram to say what the number A, or what number would be here instead of A, instead of B, instead of C, and instead of D. So I'm just going to draw out a rough Venn diagram real quick. There's question 1, and there's question 2. And there's my universal set, because somebody might not have got question 1 or question 2 right. I like to always start in the center of the Venn diagram if we can. It tells us 10 students answered both questions correctly. So B there in the diagram is going to be 10. They also tell us 4 students answered neither correctly, so there's going to be 4 outside here. And 8 students answered only question 1 correctly. So 8 students here who only answered question 1 but didn't answer question 2 correctly. It says there's 28 students in the class altogether, right? Because we're missing this piece of information here. But we know that altogether the whole class should have 28 students in it. So if we add 8 plus 10 plus 4, we get 22, right? 8 plus 10 is 18. Plus 4 is 22. So to make it up to 28 students, let's see what the difference is between 28 and 22. That's 6. So there should be 6 students here. So that's how we get our answers there. A is 8, B is 10, C is 6, and D is 4. Okay, this next question is about our set notation, right? So A union B, knowing that that is A union B, for example, right? So the first one that we have is A union B. So we try and match that up to A union B here, right? Then we have A as an element of B, or A is a subset, sorry, of B. So A is a subset of B, goes to there. The next one there is the symbol for a null set, where we can use 2 curly brackets with nothing in between them. The next one says A is not a subset of B, so it goes across to this one here. Then This next one actually looks like it didn't come out right for whatever reason. It says little a is an element of A, and actually none of these match up to that, so my apologies for that. But we'll come back to it at the end. If you knew them all, you would have been able to use the process of elimination, right? So we'll think about which ones we don't get at the end. It is the element symbol though, so if you knew that something is an element of something else, you would have got it right. Alright, the next one is A is not an element of B. It's the element sign with a little thing through it. So it's A is not an element of B. That's this last one here. The next one is A less B. So it goes up to here. And the last one is A complement, so it goes to here. Now, if we look at this one, little a is an element of big A. Well, the only one we haven't matched anything up to yet is this one, right? So obviously I should say A and B here, right? So that's a little bit tricky, but like I said, you would have gotten it if you either knew the element symbol, which is the main thing to know, or else you figured out the rest of them, right? Right, so the next one shows you a set of sports that are played by girls in a class and sports that are played by boys in the same class. So what they want you to do is name one sport that is played by both boys and girls. So if we look at the ones that are played by girls and boys, that'll be the area of interlap. So tennis, basketball, or football. Either of those will give you a point there for the correct answer. Alright, the next one is a multiple choice. The area of overlap between the two of them is called the intersection. Like for two roads in America, where two roads interlap, we call it a crossroads here, right? But in America, they call that an intersection, where the two roads overlap each other. So that's A, intersection B, because we've said A and it's intersection with set B. All right. Our next question, question 6, asks us to list the elements of A complement. If we're given a full set that looks like this. So our set A is this circle here, right? It's got the set with the elements 2, 3, and 4 in it. A complement, therefore, is going to be everything apart from what I've just shaded in red. So we're going to have 1, 5, 6, 7, and 8. 1, 5, 6, 7, 8. Again, curly brackets are ideal when we're listing the elements of a set. Alright, the next question. We've got a class of 30 students. Everyone has to study at least one language. Their options are French and German. So I've got a hint here for you. Draw a Venn diagram to help with your answers. So here's my Venn diagram. I've got F and G as my two sets. Then U is the universal set, right? So there's 30 students overall. Just trying to remember that. Right. There's 20 students to study French and 14 to study German. And everybody has to study at least one language. So there's going to be nobody outside here. Because everybody has to be either in French or German or both. Now, it doesn't tell me how many study both. I normally like to fill in the middle area first, right? But it doesn't tell me how many people study only French or only German. So actually I can't fill in any of 1, 2, 3, these 3 sections here. So another trick that we went through in class was looking at the total number, right? There's supposed to be 30 students in that class. But if we add together the amount that study French, which is 20, and the amount that study German, which is 14, we actually get 34 students, right? So that can't be right. If there's 30 students in the class, we can't have 34 people in our Venn diagram. So some of those people must be getting counted twice. And that means that 4 of them are, because we've gone over our number by 4. So if 4 of those people are being counted twice, then that's because they're in the French class and in the German class. So that will be the first thing we fill into our Venn diagram. Now, we can study or fill in the rest of French now. If 20 students are supposed to study French, that means F, our set here, should have 20 students in it altogether. We already have 4, so another 16 will bring us up to 20 students. 16 plus 4 gives us 20 students who study French. For German, it's supposed to be 14, so 10 and 4 will bring us up to 14 students who study German. Let's just double check here and make sure that we've done this correctly. It should add up to 30 students. So 16 plus 4 is 20, plus 10 is 30. 16 plus 4 plus 10 gives us 30 total students in that class, okay? So that actually does work out pretty okay then. Right, so there's a couple of questions here. How many study French and German? So that's going to be the area of overlap or intersection, and that's 4 students. How many study only French? Well, people who study French, there's 20 of them. But 4 of those study German. So the people who only study French will be 16. Alright, now we're on to the deli in some kind of a supermarket, I guess, like Spar or Super Value we have in Turleston. Okay, so a shop sells chicken wraps. There are 4 different sauces and 3 different types of chicken as shown at the table. Sally wants to buy a chicken wrap. How many possible combinations of sauce and chicken can she choose? So this is our fundamental principle of counting, right? If there's 4 options, 1, 2, 3, 4 for sauce, so she can choose one of 4, and there's 3 options for chicken. Then to get the total number of possible combinations, we multiply the outcomes for the first thing by the outcomes for the second thing. So 4 outcomes for sauce, there's 3 outcomes for chicken. So that means there's 12 possible outcomes overall. If we wanted to, we could use the listing method or whatever, but the fundamental principle of counting is a shortcut when we just need to know the numbers. So we could list out barbecue sauce with plain chicken, barbecue sauce with fried chicken, barbecue sauce with tikka chicken, mayonnaise with plain chicken, mayonnaise sauce with fried chicken, mayonnaise sauce with tikka chicken, right? So we could list all them out and we get 12 different combinations. Or we can just use our shortcut and multiply the number of outcomes for sauce by the number of outcomes for chicken. Right, so our next question here is the classic bag of marbles, right? So a bag contains 14 marbles, 2 of them are red. If you pick out a marble without looking, what is the probability that the marble will not be red? Now I've underlined not be red, because I've told you how many are red, so you need to figure out how many are not red. Give your answer as a fraction in its simplest form. Alright, so there's 2 ways of doing this, right? One of them is getting the amount of marbles that aren't red, which we can actually calculate pretty easily. If there's 14 marbles and 2 of them are red, then that means that there's 12 that aren't red, and we can put that over our total, which is 14. And that's the probability of getting one that isn't red, right? We can simplify that though. Divide both by 2, so we get 6 over 7. And that would be one of our correct answers here. There's another way of doing it too though, and it's figuring out the probability of a red marble, which is 2 over 14. Or 1 over 7. So that's the probability of getting a red. So the probability of not getting a red, what we do is we take 1, we take away our probability of getting a red. So 1, take away the probability of getting a red. It's going to be, say, 7 over 7, which is 1, minus 1 over 7. And that gives us 6 over 7 as well. Right, so either way we do it, we've got our answer here, 6 over 7, or our answer up here, 6 over 7. Alright, so this next question I kind of like because it makes you really think about what they're asking you. So, shirts in a clothes shop come in the following 4 sizes. We got small, we got medium, we got large, and we got extra large, right? So Christina, who I guess owns the shop or works in the shop, makes the following list showing the size of each of the shirts in the shop. So we got small, small, large, medium, large, large, and so on. Okay, so how many shirts are in the shop in total? We can add them all up, just count them, right? 1, 2, 3, 4, 5, 6, 7, 8, 9, all the way up to 18. Or if we want to be smart, we can say, well, there's 9 in the top row, but there's 2 rows, so 9 by 2 gives us 18, right? Christina puts one of the large shirts on a display model, then picks up another shirt at random. What is the probability that it is a small shirt, right? Give your answer in fraction form. So for this one, right, this is kind of the tough one. And I think it caught a few people out, but that's why I put it in there. So if you think about it, right, there was 18 shirts, but she takes one of them out and then picks another one. So now there's only 17 shirts, right? 17 shirts altogether. How many of them are small? Is now what we need to ask ourselves, right? So she took a large one out, so all the small ones are still in there. We had 1, 2, 3 small shirts in that pile. So there's 3 out of 17, right? 17 shirts left, 3 of them are small. So the odds of her picking a small shirt are 3 out of 17. All right, so we're on to our last two questions. We'll just look at question 12 here first. A phone factory tests its phones and finds that 3 out of every 50 phones are defective, so they don't work. What is the relative frequency of defective phones? Give your answer as a fraction. So if there's 3 defective phones out of every 50 phones, right, in our sample of 50, 3 of them were defective, then our relative frequency, how often it's come up, is 3 times out of 50. If 200 phones are produced every day, how many of these will be defective, right? So this is our expected frequency. Then what we do is we multiply our probability or relative frequency by the number of trials that we're doing, right? So the odds of a phone being defective is 3 in 50. We're multiplying that by 200 phones, right? So we basically expect that 3/50ths of these phones will be defective. So if we multiply them out, we get 12 defective phones that we'd expect to happen and be produced. Right, let's go down to question 13. If you roll a dice, what is the probability that you will roll an even number? Give your answer as a fraction in its simplest form. Right, so the number of even numbers on a dice, we have 2, we have 4, we have 6. So there's 3 even numbers out of 6 total numbers on the dice. Right, the outcomes we're interested in divided by the total number of outcomes. So this simplifies then to 1 over 2. What is the probability that you will not roll an even number? Give your answer as a fraction in its simplest form. So again, we can look and we can say how many are not even numbers here. So we know that numbers 1, 3, and 5 are not even. So there's 3 outcomes there over 6, which simplifies to 1.5. Or we can say, well, if the outcome of being an even number is a half, then we can just get the number 1 and take away the outcome of an even number, and it'll give us the outcome or the probability of an even number, and it'll give us the probability of it not being an even number. So 1 minus the probability of something happening gives us the probability of it not happening. Remember that. It's a handy rule to use. So 1 take away a half, we can say that's 2 halves take away a half, which gives us 1/2 again, right? So again, doesn't matter which way you do it, your answer is a half either way.